I am a teacher from Ilm Online Academy. I welcome to you to another video. Today we are going to have the IGCSE Chemistry review notes, and as you already know that there are 22 chapters which are present in the Chemistry IGCSE for 0620, and in today's video we'll talk about this chapter, which is chapter number 17, which is the chemistry of our environment. So there are several videos talking about the several topics that are needed in the IGCSE syllabus, and I will be making on each chapter, so therefore you can revise it better. You can check the previous chapters in our previous videos. So this is chapter number 17 of our ongoing series. So without further ado, let's just begin, and let's first talk about the contents which are included in this chapter. So the contents which we will talk today are: first we have the air quality, second we'll talk about the carbon dioxide, methane and the climate change, and third we'll talk about the water. We will learn, or you will learn, how to describe the composition of the clean and dry air in this chapter, and we will also investigate the common air pollutants and their adverse effects on our pollution. And next we will describe how carbon dioxide and methane are the greenhouse gases that are linked to the global warming and the climate change, and we will also describe the test for the presence and purity of the water. And in the last, we will talk about the main steps that are needed to purify the domestic water supply. So these are the contents which we will discuss today. So let's just begin with the first one, that is about the air quality. In the air quality, we will talk more about the composition of the air. So now we have some keywords that are related. First of all, you should know about atmosphere. In composition of our air, first you should know about the atmosphere. Atmosphere is, you can say that basically this is the layer that is present approximately 480 kilometer thick and that surrounds the earth. Atmosphere is a layer that surrounds the earth, is a layer of air and water vapors that is surrounding the earth, and it is made up of a mixture of air and water vapors. And next we'll talk about the clean and dry air. To compare the samples of the air, the water vapor is removed to produce the clean dry air, because in the dry air water vapors are removed, and clean dry air consists mainly of the nitrogen, oxygen, and we have some other gases that are present in it. Like I will show you here, we have a picture that shows the composition of the air in our environment. So this is the composition of the clean dry air. As you can see here in the picture, we have nitrogen, that is 78%, we have oxygen, which is almost approximately 21%, and then this figure shows that we have 1% of the other gases. These are 1% of the other gases, in which we have argon, right? They are present in very small quantities, and we have also carbon dioxide and some noble gases like neon, krypton and helium are present in these other gases. And we have also methane, oxides of nitrogen and sulfur dioxide. So these are the this is the composition of the clean dry air by after removing water vapors from the air, because atmosphere is a layer that is present or that surrounds the earth, and this is a layer of air plus water vapors. So if we remove water vapors, then we have the composition of the air, or composition of the clean air, that is present here in this figure. Oxygen, as we know that, which is very essential for the humans, for all the living things that are present on the earth, and this one is also essential for the respiration. Humans respire they breathe in oxygen and give out carbon dioxide. So life on earth is dependent on it. We can extract the oxygen from the air to treat the people with the respiratory problems in hospitals and also for some other purposes. Nitrogen that is found in the atmosphere, it is in unreactive form. Nitrogen has highest percentage, that is 78%, and it is unreactive. And some species of the bacteria also use this nitrogen, this atmospheric nitrogen, directly from the air to produce some amino acids in the soil. But most living things are unable to convert this nitrogen into the useful products. Nitrogen can also be extracted from the air and is used as an inert atmosphere for food packaging. We can also use this gas for food packaging. So these are the uses of nitrogen that is present in our atmosphere. Or it can also combine with the hydrogen to produce the ammonia by the Haber process, which we discussed in our previous talk. In the Haber process, for the production of the ammonia, ammonia is the starting material that is for most of the fertilizers, and ammonia is also used for making of different products. And next we talk about carbon dioxide. Carbon dioxide is almost 0.03% that is present in our atmosphere, although it is used in the photosynthesis for the plants, and it is produced by the respiration. We breathe out carbon dioxide, animals, humans, and plants take in, or plants use this carbon dioxide in the process of photosynthesis. So they make up just almost 0.03 or 0.04% of the earth atmosphere. So this is about the air quality and the composition of air that is present in our atmosphere. So next we will talk about the air pollution. The air can become polluted in multiple ways, but we have some air pollutants that are discussed in our in this chapter, so we will go through those pollutants. Human activity has contributed significantly to the atmospheric pollution and also have increased the level of oxides of nitrogen, sulfur dioxide, methane, carbon monoxide, and also carbon dioxide. Carbon dioxide occurs naturally in the air, but when it is present in the large quantities, if the amount of carbon dioxide increases in our atmosphere, so then that is considered as a pollutant for our atmosphere. When we cut down the plants, means when the deforestation increased as compared to the reforestation, then carbon dioxide level increases in our atmosphere, then it becomes as a pollutant because it is partially responsible for the global warming and also for the associated climate change. So this carbon dioxide is responsible for climate change and also for the global warming. We will talk more about the global warming in this chapter. So I will tell you about this global warming and greenhouse effect when we move further. Global warming is basically, if I told you just the definition, this is a long-term increase in the average temperature of the Earth's surface, which may be caused in part by the human activities. Human activities also increases these pollutants in our atmosphere, like the major one is the use of the fossil fuels such as coal, oil, natural gas, crude oil. They often contain some impurities that are present in it, so when we burn them, when we do combustion, so what will happen, we have a lot of air pollutants that are present or that are excreted from their burning. So after that causes the pollution in our environment. So we will talk about the air pollutants one by one. In this chapter we have some air pollutants, so we'll discuss it one by one. First of all, we have sulfur dioxides or oxides of sulfur. So first we'll talk about the production of this one and the production of this air pollutant. So from where it is produced or how it is produced. If we talk about the sulfur dioxide, we have fossil fuels such as coal or crude oil often contains sulfur as an impurity. So when we burn the fossil fuels containing the sulfur compounds, sulfur dioxide is released. So we have fossil fuels when we burn these fossil fuels, they contain the sulfur compounds, and then after that SO2, that sulfur in these compounds, when it reacts with the oxygen, it forms the sulfur dioxide, and that sulfur dioxide gas is released in our atmosphere. So you can see here how this gas is produced. This gas is produced by the burning of the fossil fuels, which contain the sulfur compounds, and then sulfur dioxide is released. Sulfur dioxide contributes to the formation of acid rain also when it reacts with the moisture that is present in our atmosphere. So this is how the sulfur dioxide is released. So the sulfur, when it combines with the oxygen from the air to release sulfur dioxide gas, SO2. So this is the equation through which the sulfur combined with the oxygen. This sulfur dioxide has been linked to most of the breathing difficulties because it irritates the lining of our respiratory tract, and it is also dangerous for the people with the asthma. So sulfur dioxide along with the nitrogen oxide is also known to react with the oxygen and the water vapor in the air to form the acid rain. So this is how this sulfur dioxide is produced. Next we will talk about its effects. The major effect of the sulfur dioxide is breathing difficulties, and also with the people that have asthma. Next, the major effect of this is the acid rain, the formation of the acid rain by the sulfur dioxide gas. How it produced? Basically, sulfur dioxide reacts with the oxygen and the water vapor that are present in the air to form the acid rain. Acid rain is harmful to life both on the land and also on the air. So this is how they become the cause of the acid rain. Like SO2 reacts with the moisture that is present there, so when it reacts, it forms, plus also oxygen gas that is present, then it forms sulfuric acid, which is H2SO4. So sulfur dioxide is the cause of the acid rain, which by the formation of the sulfuric acid, and nitrogen oxides are responsible for the acid rain by producing nitric acid. So this is the complete balance equation through which the sulfuric acid produced. The acid rain is harmful to the life both on the land and also in the water. So increased acidity levels in the lakes can also kill the fish and other aquatic life, and many plants are extremely sensitive to the pH levels. And the other major effect of this acid rain is with the building materials. We have buildings that are made up of, like, maybe you can say that calcium carbonates and also metals. So what will happen? This acid rain will cause the corrosion and damage to these buildings. They cause the damage, and some building materials react with the acid rain, and over time leading to increased rates of the damage and the corrosion. Then it will lead to the damage to these buildings. So the rain that has been more acidic than the normal by the presence of the pollutants such as sulfur dioxide, that rain is known as acid rain, which is more acidic. Acid rain is more acidic because of the presence of the acid. So in the acidic rain we have H2SO4, sulfuric acid, and nitric acid is also present there. Now I will show you here the formation of the acid rain. So this is the formation of the acid rain. What will happen? Sulfur dioxide or oxides of nitrogen from this one, you can see here, from here, this is sulfur dioxide and oxides of nitrogen that are also present there. So when they come out from the factories by the burning of the fossil fuels like coal, oil and crude oil, what will happen? These gases move upward by the wind, and then they form then we have the chemical reactions in the air, in the clouds, and then they form the acid rain. So when this acid rain comes to the land, what will happen, that acid rain will run off the fertilizers from the soil, and it has also effects on the trees and also the buildings. It has the effects on the water chemistry and water biology of our lakes, rivers, and also effects on the soil of the chemistry. So this acid rain is affecting all the life that is present on the earth. So this is how the formation of the acid rain happens, and we have also some main sources for this one, which I will show you. First we talk about the production of sulfuric acid, then we talk about its effects, and now we have some sources. So the main sources of the sulfur dioxide are by the burning of the fossil fuels. We have burning of the fossil fuels which contain the sulfur compounds, and that reacts with the oxygen to form the sulfur dioxide gas. And also the second main source is by the electricity generation using either a coal or oil, that is also included in the fossil fuels. And when we burn the petrol or the diesel in the vehicle engines, then that also produces the sulfur dioxide gas. So to prevent the harmful effects of the sulfur dioxide, we have some ways to reduce the amount of sulfur dioxide being released into the air. The removal of sulfur dioxide from the combustion gases is also done in the chimney of our industries, and that chimney gases react with the water to form the acidic solution that can be neutralized by the reaction with calcium oxide, and that process is known as basically desulfurization. Desulfurization. So we have this desulfurization. D means removal. So if we remove the sulfur, that is known as desulfurization or scrubbing, or we also call it as the acid-base reaction. So the removal of sulfur dioxide from the fumes of power stations, that is known as desulfurization. So when calcium oxide is, you can say that sulfur dioxide is acidic in nature and calcium oxide is basic in nature. So when these two react together, they neutralize it. So to prevent the formation of sulfur dioxide, it is possible to remove most of the sulfur containing compounds before the combustion. So this gives us the ultra slow or low sulfur petrol and diesel, which are required in most of the countries across the world. So we are done with the sulfur dioxide. We read the sources, effects, and also the production. Next we will talk about the next air pollutant, which is oxides of nitrogen. So oxides of nitrogen are also referred to as nitrogen oxides, like NOx. We call it, this is a journal name, and that is given to represent the several different oxides, including the nitric oxide. We have nitrogen monoxide or nitric oxide, and we have NO2, which is nitrogen dioxide. So that's why we give this journal name to these oxides of nitrogen. Oxides of nitrogen form when nitrogen and oxygen from the air react at high temperature. When the temperature is very much high, then they will react together and they form nitrogen oxide like this. And these reactions only happen at high temperature. So this is the condition. When the temperature is normal of our environment, then this will not happen, because nitrogen that is present in our atmosphere is unreactive. So whenever there is a much higher temperature, then from the air, oxygen and nitrogen react together to form the oxides of nitrogen. Like sulfur dioxide, oxides of nitrogen are also linked to the formation of the acid rain, and we have one example. Like we have nitrogen dioxide, and that nitrogen dioxide reacts with the water or moisture that is present in the air, and then it will form nitric acid, HNO3, plus we have nitrogen monoxide. So this is the balanced equation, and you can see here we have the formation of the acid rain. Acid is produced, so that's why sulfur dioxide, like sulfur dioxide, oxides of nitrogen are also responsible for the formation of the acid rain. And second most problem linked to the increased level of the oxides of nitrogen is the formation of the photochemical smog. We have a smoke. Smoke is basically, you can say that this is not smoke, this is smoke, and smoke is the combination of fog plus smoke. So when smoke and fog combines, they form a smoke. So we have one more problem, that is photochemical smoke, and that smoke results when several air pollutants react with the sunlight to form a brown haze that is seen over many large cities. So this is basically the form of a local atmospheric pollution that found in the larger cities, in which larger gases react with each other to form the harmful products. So photochemical smoke is harmful to the human health, and this is linked to the respiratory diseases in the humans and also increased number of asthma. It is linked to the respiratory diseases and asthma. And in the last, we have oxides of nitrogen that can form naturally also, mostly from the human activities. These include, first we have vehicle emission. From the vehicles, they emit the oxides of nitrogen. And then power production companies, power production industries also produce this one. And we have some industrial processes that produces oxides of nitrogen. So how they are produced and from where they are produced? They are produced from these sources. So their production is this one. So the human activities produces oxides of nitrogen, which was by the airborne nitrogen oxide pollution. And we have also one way to reduce the levels of nitrogen oxides that are emitted by these vehicles. We have some way to reduce them. How we can reduce them? We can use a catalytic converter, in which we have, in this catalytic converter, a catalyst is used, so it is connected to the part of the exhaust system of our vehicle, and the toxic gases that are produced by the engine are converted into the less harmful gases before they are emitted into our atmosphere. I will show you here a picture of the catalytic converter. So in this catalytic converter, what will happen? The toxic gases that are produced from the engine of the car are converted into the less harmful gases before they are emitted in our atmosphere. You can see here we have this one. Gases will enter here. Gases, from when they are from the exhaust gases, they will enter into one side of the catalytic converter, like you have carbon monoxide, nitrogen oxide, hydrocarbons, any exhaust gas or harmful gases or the toxic gases that are produced by the vehicle engine. They will enter into this catalytic converter. This uses a rare transmission metal catalyst, like that's why we call it as a catalytic converter, because it uses platinum, palladium, or any other metal can also be used here. So which is coated as a thin layer onto a honeycomb support, and within a catalytic converter, carbon monoxide will react with the nitrogen oxide to release carbon dioxide and nitrogen oxide. Like the equation for this one will be, when carbon monoxide that is present in this catalytic converter, that will react with the nitrogen oxide that is also present there. So when they react together, they form carbon dioxide, plus we have nitrogen gas. So nitrogen gas and carbon dioxide gas is released when these two react together. So this is, you can see here, this carbon dioxide is less toxic, but carbon monoxide and oxides of nitrogen are more harmful. So the toxic gases that are being produced by the engine are converted into the less harmful gases through this catalytic converter. Catalytic converter can also catalyze other reactions to further reduce the emission of the pollutant gases. So this is how the catalytic converter works. This is the device for converting the polluting gases from the cars into the less dangerous emissions. Carbon dioxide as compared to the carbon monoxide and nitrogen oxide is less harmful, right? And also nitrogen gas that is produced here. But if we talk about carbon monoxide and oxides of nitrogen, they are more harmful, or you can say that these are the toxic gases. So that's why you can use the catalytic converters in your car engines just for the removal, or you can say that for the conversion of the toxic gases into the less harmful gases before they are being emitted in our atmosphere. So from one side the exhaust gases will enter, and they when enter into this catalytic converter, we have a catalytic active material that is present, which is platinum, palladium, or any metal that would be there. So oxygen is also there. We have a sensor plug for the oxygen. So this is a stainless steel catalytic converter that is made up of, and through the other end we have carbon dioxide, water, and nitrogen gas is being released in the atmosphere. So this is how the oxides of nitrogen will affect, or how they cause the air pollution in our atmosphere. So next we will talk about carbon monoxide. So first we will talk about how it is produced, how this gas is produced. I think you know about the combustion. Combustion is basically the burning of the fuel. So when we burn them, we have two types of combustions. The first one is complete, and the other one is the incomplete combustion. So there are two types of combustion. Complete combustion happens in the presence of excess of oxygen, and if we talk about this one, incomplete, this happens in the limited supply of oxygen. So when there is a limited supply of oxygen, so then we have incomplete combustion. But if there is free, or you can say that excess oxygen, then we have a complete combustion. Whenever in the car engine, if there is not much oxygen that is present in the car engine, so when fuel will burn, sometimes it happens to be the incomplete combustion, and in that incomplete combustion the products that are released in this are carbon monoxide, plus we have water vapors that are released, and with the water vapors most of the times carbon soot is also released in this. But in case of complete combustion, the products are carbon dioxide plus water vapors. So complete combustion, you can say that this is the type of combustion which happens, or in which a fuel is burned in a plentiful supply of oxygen, and the complete combustion of the hydrocarbon fuels produces only carbon dioxide and water. But in case of incomplete combustion, when a fuel is burned in a limited supply of oxygen, the hydrocarbon fuels produces carbon, soot, carbon monoxide, and water is released in this one. So this is how carbon monoxide is released. So when this happens, the one possible product is the pollutant, air pollutant, which is carbon monoxide, and the incomplete combustion of any of the hydrocarbon fuel, like in case if we are talking about the petrol contains mostly the octane. So we have hydrocarbon, which is the octane. So when this octane reacts with the oxygen, O2, so it produces carbon monoxide, CO, plus we have water vapors. So this is how carbon monoxide is released. This is the incomplete combustion, and we can also compare this hydrocarbon fuel of complete combustion in a plentiful supply of the oxygen and releases only carbon dioxide and water. We will balance out this equation also. So here like this, now this equation is balanced. So this is how it produces carbon monoxide is produced by the incomplete combustion. Carbon monoxide is toxic to the humans. Now if we talk about its effects, it is you can say that this one is toxic and poisonous gas for the humans. Toxic and also poisonous. How? I will tell you. First, it binds with the hemoglobin. Hemoglobin that is present in our blood, in RBCs. So carbon monoxide binds with the hemoglobin, carbon monoxide, in RBCs, in our red blood cells. So it binds with our hemoglobin instead of the oxygen. So because oxygen binds with the hemoglobin, but whenever carbon monoxide is present, hemoglobin has a more affinity to bind with the carbon monoxide. So whenever we inhale, carbon monoxide enters, then it will bind with the hemoglobin, and when it binds them, it prevents the hemoglobin and the RBCs from carrying oxygen around the body. So this is how when it can be produced when there is a lack of oxygen getting into the engine. So it can also be made when the air inlets get blocked in a gas central heating system, as it prevents the oxygen from entering the system. So this is how it affects the humans. It attaches with the hemoglobin because it has a more affinity. Hemoglobin has more affinity to the carbon monoxide as compared to the oxygen. So whenever carbon monoxide binds with this one, it prevents them from carrying the oxygen around the body. So this is how carbon monoxide is released. And if we if we talk about how we can reduce them, now to reduce the emissions of the carbon dioxide, heating systems should be checked regularly and the inlets of these should be cleaned. You can use the catalytic converters also for carbon monoxide and also for nitrogen oxides, because these catalytic converters will convert carbon monoxide and nitrogen oxide, which are the toxic gases, into the less harmful gases. That can also prevent the harmful emission of carbon monoxide from entering into the atmosphere. So this is how the carbon monoxide affects our environment and also the humans. Next, we will talk about the second content of today's video, which is carbon dioxide, methane, and the climate change. So here we will talk about the carbon dioxide, methane, and the climate change. First of all, you should know about the greenhouse and the greenhouse gases. Carbon dioxide and methane are the greenhouse gases, and it is one of the carbon dioxide and methane are the greenhouse gases, and they increase amounts in the atmosphere that have resulted in the global warming. So if we have first greenhouse gas, this is a gas that absorbs the heat reflected from the surface of the earth by stopping it escaping the atmosphere. So global warming causes an increase in the average temperature, and because of this is leading to the climate change. So there are several greenhouse gases that includes, first we have the water vapors, second we have carbon dioxide, and the third we have methane. Methane is also present there, and nitrous oxide, sulfur hexafluoride, and chlorofluorocarbons. So in this we will look the two main greenhouse gases, which are carbon dioxide and the methane. So the release of carbon dioxide into the atmosphere, how it is released, as we already know about, the carbon dioxide is produced by the complete combustion of the fossil fuels. So fossil fuels are used to produce electricity and are the basis of many forms of the transport. So that's how the carbon dioxide is released. And if we talk about the methane, methane is released, or it's a greenhouse gas. For methane is linked to an increased cattle farming and more waste being generated by a larger populations. So how global warming and how carbon dioxide and methane causes the global warming or the greenhouse effect. Greenhouse effect is basically the natural phenomena in which the thermal energy from the sun is trapped at the earth's surface by the certain gases that are present in our atmosphere. As you can see here, this is the layer of atmosphere or layer of gases that surrounds our earth. In this layer we have the greenhouse gases that are present there, like carbon dioxide and methane. There is a suitable amount of gases are present there that provide us the thermal energy or the heat from the sun, and this is trapped at the earth's surface by the certain gases in our atmosphere. By trapping the thermal energy which is reflected from the earth's surface, the greenhouse gases maintain an average temperature or average surface temperature of about 15 degree Celsius. So if without the greenhouse effect, the average temperature would be lower and possibly maybe minus 18 degree Celsius. So that's how it is more important for the life on the earth. So at this temperature, life of the type we know would not exist at minus 18 degrees Celsius. So over 200 million years ago, levels of the greenhouse gases have remained relatively constant, but because of the human activities, this is now starting to change. So what will happen? The rays or the thermal energy from the sun is trapped by this layer that is present or that is surrounding our earth. We have carbon dioxide and methane that are present there. So less heat is trapped by the natural phenomena, but whenever the human activities is increased or enhanced, and those human activities, mostly we have the burning of the fossil fuels, and those fossil fuels will release gases like carbon dioxide, and if there are more kettles, more farming and more waste is being generated by the larger populations, and kettles emit a large amount of methane, so that's why the methane is also increases. So whenever these gases will move towards our atmosphere, there is a increased heat that is trapped in our atmosphere. So whenever the level of gases increases or rises in our atmosphere, this in turn has resulted in an increased average surface temperature of our earth. So this increase in temperature is known as the global warming. So we call it as the global warming because this increases the normal temperature that is present in our earth or in our atmosphere. So global warming to increase levels of greenhouse gases because of strong correlation between the concentration of our gases in the atmosphere and the average recorded temperature also. So what will happen here? You can see this one in our first picture. We have a natural greenhouse effect. Some of the rays from the sun is being trapped in the layer of a gas, that is layer of air, that is atmosphere, that provides us the warming effect, and some rays are reflected back. But in case of human enhanced greenhouse effect due to the human activities, what will happen? This has drastically increased. So the greenhouse gases allow the high energy or short wavelength radiation from the sun to pass through the atmosphere and reach the surface of the earth. Some of this thermal energy is absorbed and heat the oceans and the land, and some is radiated or reflected back into our atmosphere. The heat radiated by the earth has a lower energy and has a longer wavelength. So that is the difference between them. And next, the actual wavelength of this radiation falls within the infrared part of our electromagnetic spectrum, and the greenhouse gases like the carbon dioxide and methane, these two gases absorb the infrared radiations and re-emit in all the directions. So this you can see here, they are re-emitting those infrared radiations. So whenever they re-emit in all the directions, some comes back towards the earth's surface. This reduces the heat loss to the space and also increases the temperature of our lower atmosphere. That is basically known as the greenhouse effect, because absorption and reflection of the heat that warms the atmosphere works also in the similar way. So this is how the greenhouse effect. Some of the energy is absorbed in our atmosphere. Here you can see this one, in this area some of the energy is absorbed, and energy radiated by the heat, and some energy is radiated back into the space as a light and also as a heat. So whenever there is a burning of the fossil fuels in our atmosphere, that increases the amount of carbon dioxide in our atmosphere. Fossil forest fires, industry, human activities, burning fossil fuels, all these produce the various greenhouse gases, and as these increases, more and more of the sun energy is trapped, the earth warms up. So this is how there is an increase in temperature of the earth, and there are also some drastic effects due to that increase in temperature. First of all, that drastic effect of an increase in temperature is the global warming. That has increased the global warming. This is the most important and the first one, which we have also discussed right here. The temperature of the earth increases as compared to the previous. This is just because of the consequences for the earth climate. Global warming differ from country to country and also generate changes in the weather patterns that are known as the climate change. And climate change is an increase in average temperature that has caused quicker rates of the melting of the polar ice caps. Polar ice caps are also melting just because of increased temperature or the global warming. So these are the drastic effects or side effects of these increased amount of the gases or the global warming that has led to the rising of the sea level. Sea levels rises just because of this one. And increased flooding also. This is the next one. Increased flooding in some low-lying countries and faster rate of the coastal erosion. The melting of the ice cap is also causes changes to the life cycles and migratory patterns of most of the animals and the birds. Polar bears who rely on the sea ice as they travel between the different hunting grounds have been particularly affected. Increase in temperature also lead to the more severe droughts in some areas of the world. So with higher temperature, the soil dries more quickly. That is often compounded by the changes in the rainfall. So very dry soil and low rainfall increase the chances of crop failure, and also long-term arable land can become so arid, so it turns to the desert. So in the regions of most of the parts of the world like Australia or California, drying out of the grassland as a result of the climate change has increased the frequency and severity of the wildfires. So these are the drastic effects just because of the increased amount of the greenhouse gases in our atmosphere. Next we will talk about the third content of our chapter, which is water. Water is vital to the life and plays an important role in many industrial processes. So here today we will also consider how to test for the presence of water, and we will look between the distilled and the drinking water, which is the potable water. So water has many uses apart from the sustaining life. Like we have a use in our home. In our home we use the water for cooking purposes, for cleaning, and we also use it for the drinking. And in industries, water is also used there in so many industrial processes as a solvent for many different reactions, as a coolant, and also there for the cleaning purposes, and also as a chemical reactant water is used. So these are the uses of the water. Next, if we talk about the pure water, Pure water is basically, you can say that it does not have any impurity, it is pure, and the boiling point of that is 100 degrees Celsius, and the melting point of the pure water is exactly 0 degrees Celsius. So pure water is it is a colorless liquid. It does not have any color, and it boils at 100 degrees Celsius and freezes at the 0 degrees Celsius. So this is how you can check whether the water is pure or it's impure. Tap water is not the pure water. It contains so many impurities, therefore it does not boil at the 100 degrees Celsius. It will boil more than 100 degrees Celsius, temperature more than 100 degrees Celsius, and also the melting point fluctuates of the, if there is any impurity that is present there. So this is the pure water. Next we will talk about the distilled water. Distilled water is that which we get after the process of distillation. This is more, or you can say that extremely pure, because we get this one after distillation process, and it is also used in so many experiments over the tap water. We can also use this to test the purity of the water. So now we will talk about the for the presence of the water. Is the water present in that or not? So there are two methods to test the presence of the water. So these are, first we have anhydrous cobalt chloride method, and the second one is anhydrous copper sulfate. Anhydrous, that means it is that compound in which there is no water. Water is not present. Hydrated is the word that is used if water is present in that compound, if water is chemically combined to that, but anhydrous means there is a absence of water. So these are the two methods that are used here for the presence of the water. If we talk about the first one, which is anhydrous cobalt chloride, anhydrous cobalt chloride can be used for the presence of the water when anhydrous cobalt chloride, which is normally blue in color, so when it comes in contact with the water, it undergoes a chemical reaction that is known as hydration. So whenever it comes to react with the water, it forms a pink color. It changes into the pink colored hydrated cobalt chloride. So the change in color indicates the presence of the water. And next, if we talk about the anhydrous copper sulfate, when this can also be utilized for the presence of the water. So when this anhydrous copper sulfate, which is normally present in white color, when it is exposed to the water or comes in contact with the water, it gets hydrated. So when it gets hydrated, it forms, or it readily absorbs the water and forms a blue colored hydrated copper sulfate. So the change in color from the blue to the white indicates the presence of the water in these compounds, and the equations for these are, we have cobalt chloride CoCl2. This is anhydrous cobalt chloride, which is present blue in color. If we add 6 molecules of water in this, then what will happen? The cobalt chloride is converted into the hydrated cobalt chloride, like 6H2O. And this is now pink in color. So this is, by the change in color, you can easily check the presence of the water, whether it is present or not. Next, if the equation for the copper sulfate, we have copper sulfate, which is anhydrous copper sulfate, and this is normally white in color. So whenever it comes in contact with the water, what will happen? It changes into a hydrated compound, and that hydrated compound has a specific color, that is blue. So it will change into the blue. So the change in color will tell you about whether the water is present or not. So the purity of any substance, including the water, can be tested by recording its melting point, boiling point, and this is because the pure water has a fixed melting point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. So this is how you can check these one. Next, we will talk about some unique properties of water. So, the properties. Water is a pretty unique substance. It is excellent solvent for many ionic compounds, and it has many unusual properties, like it has a fairly high boiling point, like 100 degrees Celsius, high boiling point, which is unusual for its relatively low molecular mass, and it has greater specific heat capacity. So it has higher heat capacity. That is the energy required to increase the temperature, basically. So than almost any other liquid, and its density decreases when it freezes. So it has a maximum density of minus 4 degree Celsius. So its density decreases when it freezes out. So these are the unique properties of the water, and water is a pretty unique substance. It's an excellent solvent for many of the ionic compounds. So if we talk about the water pollution and their treatment, water from the natural sources and tap water can have things like tap water often contains some impurities and some substances are present there, like maybe you have oxygen, metals, plastics, we have sewage, and any harmful germs should be there in the tap water. So we need to make sure water is clean and safe. So some of the substances have the benefits, like dissolved oxygen is good for the aquatic life to survive. Some metal compounds provide the essential minerals for the life. However, some substances can be harmful, like some metals can be toxic. So if they are toxic, they should be removed. Plastic can also harm the aquatic life, so which contain the harmful microbes that cause the diseases, and nitrates and phosphates can reduce the oxygen in the water and harm our aquatic life. So we need to treat the water so that we can remove the harmful substances and make it drinkable or potable. So this is the water purification plant purifying the water for the domestic water supply. Tap water, the domestic water supply to our houses, undergoes a several purification step from the point it is collected to the point it is delivered. In many countries, domestic water is taken from the lakes and the rivers. So the first step in the purification is to remove the large insoluble objects such as the rocks, plastic bags, branches, tree branches, in a process that is known as the screening. So first of all, we have a step that is known as screening. Screening is done. After that, the water is taken into a sedimentation tank. You can see here, this is a sedimentation basin. The soil and the sand will drop down to the bottom as a sediment. You can see here, this is as a sediment, just because of the it will take some times, and just because of the gravitational force, what will happen, the sand and the soil particles will settle at the bottom of the tank. And the next process is to filter the water to remove the insoluble particles. The water is often passed through a fine sand filter to filter out these particles. So this is the process of filtration, just as we do this simple type of filtration for removing any type of particles that are present there. So water may contain some dissolved organic compounds that may cause the water to have the unwanted odor or the taste. So the organic compounds often present in low amounts that can be removed by using any activated carbon filter. So any carbon filter is used. Before water is distributed to the home, the final step is the disinfectant. Disinfection is needed to kill the harmful microorganisms that are present there. So for the removal and for the killing of these microbes, waterborne microbes, these are maybe waterborne microbes such as bacteria that can cause the diseases. Different countries use the different methods to disinfect, but one of the most common method is to add the small amounts of chlorine gas. Small amounts of chlorine gas are being added, so that will typically used. So chlorine is added at a concentration of almost 2 to 3 milligram per decimeter cube. So this is how you can do the purification. So after this disinfection step, we have a treated water storage that is often used for the human consumption, that is supplied to the houses or domestic supplies. So the first step here is water is filtered to remove the debris and the soil particles. Second, we have a filtration process that is there to remove the particles, and then water enters the sedimentation tank. Fine sand filtration removes the remaining impurities, and in the last we have a disinfectant. Disinfection chlorine is being added to kill the microbes and also ensure its safety. So this is how you can treat the water or purify the water for the domestic purpose. So domestic water supply go through several purification steps, included the screening, sedimentation, and filtration we have, and also in the last we have a disinfection to remove the solids and the particles that are present there, to remove the microbes. So the disinfection, carbon filtration is also there to remove the odors and the taste, and chlorination is done to kill the harmful microorganisms. So this is all about today, chapter number 17, and this is the water purification plant, as you can see here. So today we talk about the air quality, composition of the air. Next we talk about the greenhouse, global warming, and in the last we talk about the water, test for the presence of the water, and pure water, distilled water, the substances that are present in the water. Some are beneficial, like dissolved oxygen is beneficial, and also there are some harmful substances like metallic compounds, sewage, microbes, germs, nitrates, phosphates. So all these are the harmful one. Plastics also are present there. So before supplying the water to the households or for the drinking purposes, water is passed through a water purification plant. So that water purification plant is there for purifying the water for the domestic water supply, and we supply to our homes undergoes the several purification steps which we discussed today, and from the point it is collected to the point it is delivered. So raw water mostly in most of the countries, from the lakes, from the rivers, from the reservoirs, we collect the water, and then water is supplied to the households. So this is how the water purification is done. So this is all about today, the complete revision of chapter number 17. Hope you understand all this. If you have any question, any query, you can ask in the comment box. If you like our content, then please subscribe our channel and share the video with others also. So we will meet in the next one.